Hello, let us look at some AP practice questions for Calculus BC. So here it comes that there is no snow on Janet's driveway when snow begins to fall and then it goes on. We realize here is that the snow accumulates based upon this model where T is measured in hours since midnight. Okay, that's important here. And Janet starts removing snow at 6 a.m., meaning T is equal to 6, and then the rate G of T in cubic feet per hour at which Janet removed the snow is given in this way. Alright, so the question A is how many cubic feet of snow have accumulated in the driveway so accumulating, that means we have to use the F of T. So in case of A, the way which we can calculate is we're going to take the integral since it started from midnight, so 0 through 6 for F of T dt. Now, so in our calculator, what I could have done is I'm gonna press math, number 9, and then we are going from 0 to 6, and let me just try to type this one in. 7, I'm gonna call it as x e to the cosine x. So once I have done this one, then this basically tells you exactly the same thing as before. Instead of t, we have x, press enter, and that becomes our answer. So using that, I'm just going to put it on the side. I guess our answer is 142.3. And then unit will be how many cubic feet? So cubic feet. That would have been our answer. How about B? Find the rate of change of the volume. So how much volume is changing at driveway at 8 a.m. That basically means B. F of T is how much is coming down, and then G of T is how much is going away. So all we have to do is F of 8, that's the rate where it's coming down, minus G of 8, rate which is going out, and that basically becomes our answer. Here, then we end up getting 7 times 8 times e to the cosine of 8. Now, and then minus. But what is g of 8? 8 belongs right here on the bottom, so I just have to subtract 108. Then it seems like negative 59.58. So negative 59.6. And then that's how much is being changed. So cubic feet per, in this case, hour. All right, let's go for C together and see what happens. Now C is let H of T represent the total amount of snow in cubic feet that Janet has removed from the driveway at time T. So basically what we're looking for is this one, this rate, and H of T goes from 0 through 9. But notice that due to piecewise function here, what we end up getting is we have to get another piecewise function. So let's try to look at C. H of T first can be defined by where t goes from 0 through 6. So when t goes from 0 through 6, nothing happens. So therefore, we can just simply write down 0. But how about uh, t goes from 6 to 7? Then what happened? That's right. Basically, what it ended up happening is whatever already acquired, the rate will be 125, and then we have to integrate that. So we end up getting 125 t. That's basically what we end up getting. But the thing is, um, this t is only affecting hours after 6. So all we have to do is minus 6 here. Then you will realize that after 1 hour of work, Janet probably, meaning h of 6, would have been equal to, h of 7 must be equal to 125, because for 1 hour she finished shoveling 125 cubic feet per hour, which ended up being 125. Now, how about where t goes from 7 to 9? Then we have to add 125 to whatever she's doing afterwards. So we end up, but the rate is 108, so we get 108 and t minus 7, because we're talking about hours after 7 a.m. So that becomes our answer. All right, now then let's try to look at choice part D. How many cubic feet of snow are on the driveway by 9 a.m.? So we know that the snow is continually falling down till 9 a.m. now, but Janet is removing the snow by this much. So all we have to do is, so why don't I just call it total amount as A of t would have been equal to, goes from 0 through 9 for f of t, that's how much of snow is falling, and then subtracting the total amount, which is h of 9. Now we can calculate the first portion from the calculator. And I'm just going to change the time or boundary from 0 through 9. And that's basically what we end up getting. And then we'll have to subtract h of 9. h of 9 in fact becomes 125 plus 2 times of 108, which is 216. So 125 plus 216, then we end up getting, that's what's left. So we our final answer should be 26.3 cubic feet is left. And that becomes our answer. Let us look at question number 2 here. A zoo sponsors a one-day contest, name a new baby elephant. So it continues in this way. Notice that the number of entries in the box t hours after noon is modeled by the function e. So this is number of entries by the time. Now, so use the data, approximate the rate when t equals 7. So now we want to approximate the rate here, that's part A, but that can be approximated by the values around it, meaning average rate of change. So by using the mean value theorem, we can somehow approximate that a little bit. So here we end up getting e of 7 minus e of 5 divided by 7 minus 5. That's basically what we end up getting. Then difference in the entries would have been basically 8 over 2 becomes 4 Now hundreds of entries per hour, so 400 entries per hour. That's basically what we end up getting for A. Part B. Use a trapezoidal sum with 4 sub intervals. So basically we are looking at the first one here, second one here, and third one here, and the fourth one. And that will be our dimensions for trapezoid. Now, to approximate this value, so we're going to try to do this one on the bottom. And we need to, using the correct unit, we need to explain the meaning of this. So, first, let's try to go for this one. By our trapezoidal rule, we realize that our first trapezoid, the height is 2, and then base 1 is 0, base 2 is equal to 4. So we end up getting E of t dt, now 0 through 8. I believe that was 8. So can be approximated. The first trapezoid would have been, as I mentioned, 0 plus 4, base 1 plus base 2 times height, which is 2 divided by 2. Second trapezoid is 4 and 13, and then height is equal to 3 hours. So here we get 4 plus 13 times 3 was the height, divided by 2. And then third one is 13 and 21. 21 over 2 times 2. 2 was the width between them. The last one is 1 here, so 21 plus 23 times 1 divided by 2. So that's basically what we end up getting. Then here we end up getting these two cancels out. We get 4. Second one, now in this case becomes 17. 17 times 3 becomes 51. So we end up getting plus 25.5. Here becomes 34. Then 2 cancels out, plus 34. And then the last one becomes 44 divided by 2 becomes 22. Now, so if you have to add them up, we can simply say 4 plus 25.5 plus 34 plus 22. That's 85.5. And we have to divide that by 8, which is 10.68. So here we get 85.5. Now, when you divide this one by 8, and then explain the meaning in terms of entries. So, e to the t, e of t and then dt over 8 is about now, then I guess we can say 10.7, which is about 11 entries per hour. 11 entries. But in this case, unit is hundreds of entries, so what we end up having is 11 hundreds of entries. Now, this basically talks about the average value. You see, average value of E of t over the period. So, on average, basically meaning is on average, there are 1100 entries in the box during the time. All right, let us move on to the next question, part C. The volunteers begin to process at 8 p.m. and then the rate is given by this way, hundreds per entries per hour. Now, according to the model, how many entries has not been processed by the midnight? So then, total at this point, total would have been 2300. So 23 minus that integral that we saw, p of t 8 through 12 for P of t dt. Now, then in this case, let's try to find the difference and then see what we end up getting. So using the calculator over here, we have 23 minus math, and then integral becomes number 9. It was from 8 through 12. For the function here, x cubed minus 30 x squared plus 298 x minus 976. And then we're taking the integral against x, so we end up getting 7. So using that, we can say that the answer is 7. Now, but the question is, how many entries has not been processed by the midnight? 7 was hundreds of unit entries, so we can just write down this implies a 700 entries has not been accounted for. Now let's look at part D. According to the model from part C here, what time are the entries being processed most quickly? Now, so basically what we're talking about here is processed most quickly, meaning the rate was the highest. So what we end up getting is part D. We can do several different ways. We can take the derivative and set it equal to 0. Or we can sketch and then see where the highest point might have been at. So what I'm going to do is this, y equals, I'm just going to put down the values as they are. X cubed minus 30 x squared plus 298x minus 976. Now, window here, x goes from minimum is 8, maximum is 12. Now, so in case of zoom, I'm going to go for zoom fit. Zoom fit is number 0. Once I do that, then keeps the x value and then change the y value as it needed. So I'm going to I just press 0 and then we'll see the graph that goes up and down in this manner. You can see that. Alright, so that's the graph. Now, then we can see that rate is the highest, will be at the end. Not here, this is the local maximum, but this will be the highest. So I just have to find out what that value is. Then to find the value, second, calc, m value will be choice 1. And x value that I'm looking for is 12. We'll see that y value was equal to 8. So x value is equal to 12. Based upon the question, at what time most quickly? So by graph, we see that when x was equal to 12, or t is equal to 12, I should say, the entries were processed most quickly. Alright, so that's basically how we can answer that portion. Let's try to go for the next question. Number 3. A particle is moving along a curve so that its position at time t is given in this way. So we're looking at parametric function here. X of t is given in this manner, but while y of t, the only thing that we know about that is the dy dt. Now, first, find the speed. How do you find the speed? You see, speed is the absolute value of the velocity. But since the velocity is the vector component here, as you can see, what we end up getting is square root of x prime of t plus square here, and y prime of t square. So now, since it seems like we will be using that a lot, so what I'm going to do is this. Why don't I plot those things? So x, I'm going to call it derivative of this one becomes simply 2t minus 4, or 2x minus 4. So y sub 1 is the x prime, and dy dt becomes y sub 2, so I'm going to call it x e to the x minus 3 minus 1. All right. So here we have, as I mentioned, when t is equal to 3. So then, what do we end up getting? So second calc, value, and I guess I should try to sketch the values accordingly. 0 through 4 is what I'm looking for, so I'm going to set the window as 0 through 4. And then I'm going to go for zoom fit, which should have been equal to 0. That's the dx dt, and second one will be dy dt. All right, so here once again, I'm going to calculate the value here, number 1, x equals 3, right over here, and then in case of y, it became 2, and then if I'm looking for the here value once again, 3, once again it will be equal to 2. So both way it was equal to 2. So then here our answer was 2 square plus 2 square, which basically becomes 2 square root of 2. Now there will be the speed. Now, and in terms of meters, so we're going to have meters per second. Now, how about B? Find the total distance. You see the total distance in this case, we can find it by the speed, or we can call that as arc length. So then, total distance is which goes from 0 through 4. So here we have 0 through 4, and then square root of x prime of t square plus y prime of t square dt. Then using the calculator, what I can do is this. So I'm going to integrate this one, which is number 9, and boundaries are 0 and 4, and square root of x of t was the y sub 1, so I can go for vars, y vars function, and square, plus, and then same deal, VAS, variables, y variables, and then function, second one, and then square. But we know that we're taking the derivative against x anyway, so if you have to press enter, we're going to see what the values will be. So the answer was 11.6, I guess. But 11.6 meters. That would be the total distance. All right, part C. Find the time t when the line tangent to the path of the particle is horizontal. So that means we are looking for dy, dx has to be equal to 0. This basically means dy dt over dx dt will be equal to 0. Only way that's possible is when dy dt, which is equal to e to d t times e to d, t minus 3 minus 1 has to be equal to 0. So that means this one has to be equal to 0. So let me go back to the calculator. So when I graph this one, what is that point? That's where dy dt, the red one, is equal to 0. So I'm going to calculate 0, which is number 2. Left bound seems to be 0 to the 4. I'm just going to call it as 2. And then right bound seems to be around 3. So I'm just going to type in 3. And guess. That's right. So that's the value that we end up getting. Here we have 2.207. So t was about 2.21-ish second. Now, but part C, what we have to do is this, is the direction of the motion of the particle, left or towards the right. Left or right is determined by dx dt, because x is a horizontal component to that. So then dx dt in this case, when t is equal to 2.21, here the formula was 2t minus 4, so 2 times 2.21 minus 4. We know that this one is greater than 0. So therefore, it's moving right. All right, so part D. There is a point with x-coordinate 5 through which the particle passes twice. Find each of the following. Find two values of t when that occurs. So let's look at it. X-coordinate is 5. So then D, this coordinate has to be 5. So t squared. So x of t has to be equal to 5. Then we can easily see that t squared minus 4t plus 8 has to be equal to 5. Then we get t squared minus 4t plus 3 is equal to 0. Then we know that t minus 1 and t minus 3 has to be equal to 0. So t becomes 1 over 3. And those are the two values of t that will happen. Slope of the line tangent to the particle at that point. So basically we are looking for slope basically means dy over dt, dy over dx. And then we can do that by, earlier what we have done is what, 2t minus 4, that's the other way around, which was this value, t e to the t minus 3 minus 1 over dx dt was 2t minus 4. So when I plug in 3, then what happens? When t is equal to 3, then we end up getting this becomes 0. So we get 3. So 3 times 1 minus 2, which we get numerator is 2, and denominator becomes 2 as well, which is equal to 1. So that's basically what we end up getting. Now, how about when t is equal to 1? When t is equal to 1, this portion is equal to 1, and then we end up getting e to the negative 2 minus 1 over, when t is equal to 0, t is equal to 1, we get over negative 2. So that becomes a slope at each time. Now, what is the y-coordinate of the point, given that it is this? Now, in order for us to calculate the y-coordinate, knowing that y sub 2 is given in this manner, y when t is equal to 3, for example, because it has to be the same point, so y sub 3 or y sub 1 would be exactly the same location. So in case of y sub 3, basically it is equal to y sub 2, because we know, plus the change between 2 to 3 for dy dt. Now, here y sub 2, as was given, was equal to 3 plus 1 over e. And then I just have to calculate this portion. I'm going to use the calculator to do that. Then here we have dy dt was the red one. So 3 plus 1 over e to the 1 either way, and then plus integral, which is 9 from 2 to 3, and then the expression is y sub 2 and it was about dx. Then we get to see that the answer has to be equal to 4. So 4 will be the location. Alright, so we'll stop here and I'll see you later. Bye bye.